My name is Dr. Rodriguez. I am a weight loss doctor in weightrx.org. Did you know that semaglutide, a glucagon-like peptide 1, GLP-1, receptor agonist, has gained significant attention for its efficacy in weight loss and metabolic regulation? One of its key mechanisms is decreasing hepatic glucose production, a vital factor in improving glycemic control and facilitating weight loss, particularly in individuals with type 2 diabetes or insulin resistance. The following sections explain how semaglutide achieves this effect. Gluconeogenesis, the synthesis of glucose from non-carbohydrate precursors like lactate, amino acids, and glycerol. In individuals with metabolic disorders such as obesity or type 2 diabetes, hepatic glucose production often becomes dysregulated, leading to hyperglycemia. The liver continues to produce glucose even when blood glucose levels are elevated, exacerbating the problem. Semaglutide targets this dysfunction through several interrelated pathways. Semaglutide enhances glucose-dependent insulin secretion from pancreatic beta cells. This is crucial because insulin directly suppresses hepatic glucose production by inhibiting gluconeogenesis. Insulin downregulates key enzymes involved in gluconeogenesis, such as phosphoenolpyruvate carboxykinase, PEPCK, and glucose-6-phosphatase, promoting glycogen synthesis. Insulin facilitates the storage of glucose as glycogen in the liver, reducing the substrate availability for glucose production. Additionally, semaglutide improves peripheral insulin sensitivity, reducing the overall glucose burden and further downregulating hepatic gluconeogenesis. Semaglutide inhibits the secretion of glucagon, a hormone that opposes insulin and promotes hepatic glucose production. In a fasting state or during hypoglycemia, glucagon stimulates both glycogenolysis and gluconeogenesis to maintain blood glucose levels. By suppressing glucagon, semaglutide significantly reduces these processes, particularly in individuals with hyperglycogenemia, a common feature in type 2 diabetes. Weight loss induced by semaglutide contributes to decreased hepatic glucose production. Excess visceral fat is associated with hepatic insulin resistance and chronic inflammation, both of which drive increased HGP. Semaglutide reduces body weight and adiposity, thereby alleviating these metabolic stressors and enhancing the liver's responsiveness to insulin. Semaglutide also exerts effects on the central nervous system, CNS, to regulate hepatic glucose production. GLP-1 receptors are expressed in key areas of the brain involved in energy and glucose homeostasis, including the hypothalamus. Activation of these receptors by semaglutide enhances the brain's ability to regulate peripheral glucose metabolism. For instance, semaglutide modulates autonomic nervous system output to the liver, reducing the signaling that promotes excessive gluconeogenesis. It also enhances the brain's sensitivity to insulin, indirectly influencing hepatic glucose regulation. A significant contributor to elevated hepatic glucose production in metabolic disorders is lipotoxicity, caused by the accumulation of free fatty acids, FFAs, in the liver. High FFA levels stimulate gluconeogenesis and impair insulin signaling. Semaglutide decreases lipotoxicity through weight loss and improved lipid metabolism, thereby normalizing hepatic glucose production. Chronic low-grade inflammation, often seen in obesity and diabetes, contributes to hepatic insulin resistance and dysregulated glucose production. Semaglutide has demonstrated anti-inflammatory effects, such as reducing circulating pro-inflammatory cytokines like TNF-alpha and IL-6. By alleviating inflammation in the liver, semaglutide restores insulin sensitivity and suppresses excessive glucose output. Emerging research suggests that GLP-1 receptor agonists like semaglutide may influence the composition of the gut microbiota, which plays a role in glucose metabolism. By promoting a healthier microbiome, semaglutide may indirectly reduce hepatic glucose production through improved metabolic signaling between the gut and liver. Clinical trials have consistently shown that semaglutide reduces fasting plasma glucose and improves HbA1c levels, indicative of its impact on hepatic glucose production.
For more information on this topic, please subscribe to our channel or text our clinic number. Brought to you by weightrx.org.